Welcome to Bio 3. Today we'll talk about the first half of the photosynthesis. It is called light reaction. So light reaction, of course, it involves light. So we'll briefly talk about the spectrum of the light, and also we'll talk about the two photosystems that are involved in the light reaction. So we'll first talk about pigment, because pigment is the light absorbing agent. And in plant, okay, most of the leaves are green. Why? Because they have chlorophyll. And then some vegetable or plant, they are red or orange color because they have carotenoid. And then we have something, the last but not least, we have something called phycobilins. Phyco means alga. It's not very good handwriting. Bilin means bile. Phycobilin, they can be blue in color or red in color. And in cyanobacteria, they are kind of a blue or green. So we call cyanobacteria has a different name. It's called blue-green algae. Blue-green alga. So because their color is kind of blue or green, but red algae, they are red in color. Okay, the pigment of the plant, okay, they have two types. One is for photosynthesis, one is for protection. We will be focusing on the photosynthesis one, the photosynthetic pigment. We talk about the chlorophyll, carotenoid, and then we'll briefly talk about chlorophyll A and B, keratin and xanthophyll. So xanthophyll, yellow, keratin, those are the pigment. Also for photosynthesis, we'll talk about different spectrum of these color pigment. So if you should do this experiment in the lab. So we'll ask you to scorch leaves so that some of the pigment will be deposited on a filter paper, or we call it chromatography paper. And then we will put the chromatography paper in a solution. As the solution move up on the chromatography paper, then different pigment can be separated. So you can see in here, we have chlorophyll B at the bottom, and then chlorophyll A is lighter, and then xanthophylls, they are yellow, they are lighter. The lightest one is keratin. So you should see at least four bands of colors. So let's talk about chlorophyll. Chlorophyll is a pigment allowed to capture solar energy, and this field makes photosynthesis possible. So what is light? Chlorophyll, so what happened in chlorophyll? Why does it look green? Well, the reason is that chlorophyll absorbs color spectrum, absorbs red color, it absorbs orange color, it absorbs blue and purple color. The only color it does not absorb is green color. Because of that, green color get reflected from the leaf, and then that's why all the leaves look green when they have chlorophyll. But we'll go deeper to look at what is light. Light is a form of electromagnetic spectrum radiation, EM radiation. Light photon travel in wave and particle. Okay, this is a little bit not okay in terms of physics. If you really dig into physics, if you are really interested in physics, then you know that light is an electromagnetic wave, but it displays both the wave property and also particle properties. It is kind of confusing, it has been like a mystery in physics for many years. Still, people just say, oh, it travels as wave and also particle. Light is the only thing that displays both properties. It's very interesting. Sorry, I'm not a physicist. I don't understand it, but I know that it is travel in wave and particle. So plus particle. Okay. I'll erase it. And particles. And then often when you travel as wave at the speed of, okay, it gives you the speed of light. You do not need to memorize it. No need to memorize the speed of light. I won't test you on this. Okay, wave. This is something that you need to know for your basic understanding. Wave travel like a sine wave. Okay, sine wave. From the base to the crest, we call this amplitude. From one crest to another crest, we call it lambda or wavelength. It can be from a trough to another trough. So this is a one wavelength. Or we can call it one period. This is a one period. Period. One period equal to the symbol of period is T. Small letter T. One period. The difference. Okay, you may think, how come period and wavelength they are the same? From crest to crest we can call it period. From trough to trough we can call it wavelength. But their unit is different. Okay, wavelength unit is a nanometer. It's not good handwriting. Nanometer is nm. Nanometer. Period is in terms of a millisecond. Okay, so the unit is different, but it talks about also from crest to crest or from trough to trough. So amplitude tells you how much energy that wave or the light contains. So high energy wave, so the light will be brighter. The amplitude of the wave will make the light brighter or dimmer. Frequency. What about frequency? Okay, now it talks about wavelength. So remember, okay, from crest to crest we have this wavelength lambda, and also we talk about amplitude. Frequency is equal to the number of waves per second. The unit is hertz. So you can compare A and B. Which one has a higher frequency? Since we see that, okay, it is the same time, so the x-axis basically describe how much time. So in A you have 1 lambda and 2 lambda, so you have two waves. You have two waves in A, so you have one wave here, and then you have another wave here. In B you have, okay, 1 wave, 2 wave, 3 wave, and 4 wave. So you have 4 wave in B, okay? So because A and B, they are of the same amount of time, and B has 4 waves in the same amount of time, A has 2 waves in the same amount of time. That's why B has a higher frequency. So other than amplitude, okay, the higher the amplitude, the brighter is the light, and frequency is also the same. Higher the frequency, higher the energy level. What kind of energy level we're talking about? We're talking about penetration power. Penetration power. Yes, some light. Okay, light. Normally you may think, oh, light can go through a paper, right? If you put a light going through your thumb, let's say, the light, you will see the red light, or you can see the light can go through the skin maybe. But X-ray, you know that X-ray, we always take X-ray. X-ray has a very high frequency. It can go through our body, but it cannot go through our bone. That's why under the X-ray film, bone they looks white, because the bone, they have metal like calcium that reflect the X-ray. But X-ray has a high frequency, so it can penetrate our tissue, the organ, the muscle, the skin. And that's why we can see inside our body using X-ray. So we have 3 things that we learned about wave so far. Amplitude. Amplitude is basically the height of the peak or trough. In terms of meter, it should be in terms of nanometer. Wavelength is the distance between 2 peaks or 2 troughs. The unit should be a nanometer as well. The frequency, number of waves in 1 second. In one number of waves in that pass by, forget about pass. Number of waves in 1 second is fine. Number of waves in 1 second, hertz. A wave passing by in each second. Okay, so number of waves in 1 second is fine. Okay, frequency, and then you also know about period. Period is also the time period. Period is very similar to wavelength. For period, number 4. Let's put point number 4 here. Period. Period is, instead of the distance, is the time. Is the time between any 2 peaks or any 2 troughs. Instead of meter, it will be millisecond. Millisecond. It will be millisecond here. So the definition of wavelength and period, they are very similar. We just change the distance into time and change the unit from nanometer to millisecond. See, wave